Hi everyone, welcome to our presentation. I'm Luis van Dirk Albano and together with my group mates Reynaldo, Joshua, and Roger, we'll walk through our assembly program today. We'll show you a step-by-step sample run explaining how the program works and highlights of the key features.
Yes, our program is menu-driven system that accepts numbers and whole number, perform input validation, and show result in ascending and descending order. Let's dive in.
First, the program displays a main menu. Notice that if we enter an invalid choice, like 5 here, the program responds with an error message.
Exactly. The program then prompts us to try again, ensuring that users only pick valid menu options 0, 1, or 2. This is handled using input validation in assembly.
Now let's try running the first number of the code, which is the number 1. And as we can see here, it displays enter an integer. So let's first try, let's say ABC. And when we press that, the text will display an error that the input is not valid integer. Please re-enter because the alphabet is not valid when entering in this code. So let's try another one, which is -12. And when we press that, it also inputs error because the negative, or yes, this negative right here is also invalid. Let's press another one, which is 25. And let's press 14 and now 9. And when we press, let's say, times 7, the the input also inputs error, which it inputs an error that says input is not valid integer, please re-enter because of this x right here. So this one is invalid. So now let's try 7 and let's try 30. So as you can see, the input uh, accepted because we don't have a
So if the user types letter or negative numbers, the program asks them to re-enter the value. So this is done using ASEA checks and conditional jump into NASM assembly.
After successfully entering all 5 numbers, the program displays the number in ascending and descending order. The numbers we entered is number we entered is 25, 14, 9, and 7 and 30. In ascending number, it is 7, 9, 14, 25, and 30. And the descending number is the 30, 25, 14, and 9, 7.
The sorting logic is implemented using nested loops in assembly, comparing values and swapping them as needed. Then the program returns to the main menu. So now we choose the menu number 2, which is enter the 5 words. So for example, we type apple but accidentally type 1 and 3. So now we have come now to the menu number 2, which is the enter 5 words. So we will input number 2 and then we will input the word number 1. So let's, for example, say apple, but we accidentally input 1 and 3. So there's an error message saying that words may only contain letters and please re-enter. So apple, orange, and then for example, we accidentally again put it this symbol. Then again, it will say that words may only contain letters and please re-enter. So let's say table, and then for example, we accidentally type any space in our word. So it will say that an error message saying that words cannot contain spaces and please re-enter. So we will have to remove the spaces and type again. And then the last word, which is shop. And then
okay. Next, we select option 2 to enter words. The program validates each word, making sure it contains only letters and no spaces.
Yes, and after validation, it converts words into a coded format for demonstration. As you can see, the sorted ascending, you can see the A it changed to 1 and the O it changed 4 and 5 it changed U because
After conversion, the program sorts the word alphabetically ascending and descending, showing the output clearly. And the sorted ascending is 1PP 12, the second is 4R 1R G2, third is 5N 3T, 4 is CH1 LK, 5 is T1B 12, and the sorted ascending descending is T1B L2, and the second one is CH1 LK, the third one is 5 and 3T, and the fourth one is 4R1 and G2, and the last one is 1PP12.
This part demonstrates string handling in assembly, including validation, conversion, and sorting. Notice how the program ensures clean and readable output before returning to the main menu.
And finally, we input 0. The program gracefully terminates, ending the execution. Finally, we choose option 0, which is right here. The program gracefully terminates and ending the execution.
so this show proper program control flow with loops and exit condition implemented in assembly.
To summarize, our program demonstrates several key concepts in assembly. Number one is the menu-driven interface. Second is input validation for integers and the words. The number three is numbers and words sorting. And the fourth one is string conversation logic. And the last one is error handling and users prompt.
By using NASM assembly, we handle loops, conditional jumps, ASCII checks, and data storage, all at a low level but organized way.
Thanks for following along. That concludes our step-by-step run and explanation.
And we hope this gives you a clear understanding of assembly programming in practical interactive projects.
And now, feel free to try modifying it or experimenting it with other inputs to see how the program reacts.
Thank you for watching our presentation.